Hello everyone, this is Mr. Underkoffler, and today we're looking at the guided notes called Solving Two-Step Equations. This is a follow-up to the lesson we just did the other day, where I was introducing you to equations that had two things happening to the variable and two then inverse operations that need to be done. Follow along. It says, since the word inverse means opposite, that's what the word inverse is, it's a synonym for the word opposite, the order that you do your inverse operations should be opposite from order of operations. Well, you guys remember what order of operations is. Order of operations is parentheses, exponents, multiplication, division, then addition, subtraction. Called PEMDAS is what we sometimes call that. So PEMDAS is normal order. But since the word inverse means opposite, then your inverse operations will be done in the opposite order from normal. And so instead of using PEMDAS, you will use the reverse of that, which I know humorously would be called SADMEP. What that means is that the first inverse operation that you will do will be subtracting or adding by something, and the second inverse operation you will do will be dividing or multiplying by something. There is no exponents or parentheses on any of the problems today, so that's kind of nice. We will eventually get some problems with parentheses later in this chapter, and then we'll look at exponents at a later time. But that's how this is going to work. So I have some examples typed up for you. Problem number one, let's take a look at this together. The directions say solve using inverse operations, which clearly you're going to have to do because right now the variable is definitely not by itself. As you can see, the variable x has a 4 right next to it. Of course, we know that means being multiplied by 4. And then it has a subtracting by 13 to the right of that. So that's the second thing happening to the variable. And ladies and gentlemen, when you answer what's happening to the variable, you are following the order of operations, your traditional order of operations, which is PEMDAS. That's how you answer what's happening to the variable. But the inverse operations are going to be done in the inverse order. And I've talked to you guys about this before in the previous lesson. What was last happening to the variable will be the first inverse that we end up doing. What was first will be inversed last. That's how this works. So the first inverse comes from the inverse of subtracting by 13, which is adding by 13. We do that first to both sides. Notice how I line it up. The plus 13 is underneath the minus 13. That's the part you're inversing. And then it has to be done on the right side of the equation, so it's underneath the negative 73. Before we work down, we will look for subtraction, and we will make it adding the opposite. And on this problem, you'll have to do this real quick with your pencil because I did not already type this up for you on your copy. So you'll make the minus 13 become plus negative 13, and now you will see how this works when you work down. Negative 13 plus 13 gives you 0. Negative 73 plus 13 gives you negative 60. But check it out. The 4 that you saw on the 4x, it's still there. When you take 4x plus 0, that'll simplify to just 4x. So this does not magically make the 4 disappear. No, no, no. I know you guys are all very used to having the variable by itself at this point in time because the equations we've been solving, a few days ago only had one thing happen to the variable. But you can see here, the 4 is still on the x. So now it's time for the second inverse operation. The inverse of multiplying by 4 is dividing by 4. So we do that to both sides now. 4 divided by 4 gives you 1, so we have 1x. Negative 60 divided by 4 gives you negative 15. 1 times x is the same as x. That's the multiplicative identity property. And now we finally have the x by itself, which means now we finally have solved the equation. We found the one and only number that x could equal to make the original equation true. If you don't believe me, you could actually take that negative 15 that we just found out that x equaled. You could substitute it back into the original equation. 4 times negative 15 would be negative 60 plus negative 13 would equal the number on the right-hand side, negative 73, proving that this actually is the solution to this equation. It's the one and only number that x could equal to make the original equation work. And as I was trying to explain, inverse operations are done in the inverse order. Notice, instead of PEMDAS, It's SADMAP, meaning the first part was the subtracting or addition. The last inverse was the dividing or multiplying. That's what I mean by the order of SADMAP. And don't take my word for it that that's going to be the easy way. If you would not do the inverse of SADMAP, if you would actually divide by 4 first, then it gets really complicated. And I have this typed up on the far right of your paper. If you would divide by 4 first, the distributive property would have to kick in. You would have to divide the 4x and the 13 both by 4, which would give you 1x, but then would give you 13/4, which is 3 1/4. Yes, 1 times x is the same as x, but then you would have to look at all these mixed numbers you would now get. Negative 73 divided by 4, negative 18 1/4. This is not the easy way, ladies and gentlemen. I think that's pretty obvious. Then you would do the inverse of subtracting by 3 1/4, which is adding by 3 1/4. Now, you would eventually get the same answer that I showed you earlier on problem number 1. But I hope you can clearly see that would be the hard way of doing this problem. I don't think any of you want to do it that way. This is why it makes sense that inverse operations should be done in the inverse order from normal. Instead of PEMDAS, do your inverse operations in the order of SADMAP. All right, one more example that's fully typed up for you. Take a look at this together with me on the screen. What's happening to the variable? Well, since the m is over -5, that means it's being divided by -5. Then you can see a minus 29 to the right of it, which means it's being subtracted by 29. And that is traditional order of operations. That's PEMDAS, where it's division or multiplication, and then later subtraction or addition. But then your inverse operations are done in the inverse order from normal. So instead of PEMDAS, it's SADMAP, which means the first thing gets inversed last. The second thing, subtracting by 29, gets inversed first. And the inverse of subtracting by 29 would be adding by 29. The inverse of dividing by -5 would be multiplying by -5. So first inverse, adding by 25, we do it to both sides. Remember, the equal sign is what separates the left side from the right side. That is your invisible border, so to speak. Notice how I lined up the adding by 29. I put it underneath the minus 29 because that's the part you're inversing. So the way you line this up is very important. Now, before you work down, you would find subtraction, and on this problem, it's on the original problem. You make it out in the opposite, then you can work down. 24 plus 29 on the left gives you 53. Negative 29 plus 29 on the right would give you 0. So you would have m over -5 plus 0. Anything plus 0 is just itself. So the fraction of m over -5 plus 0 would give you just m over -5. We always simplify what we can. Like in this case, the adding by 0 just gives you the fraction itself. We always simplify what we can before we do the second inverse operation, which we'll now do. Multiply by -5 on both sides. You will get negative 265 when you take positive 53 times -5, negative 265. The right side will give you 1m, and finally you will get negative 265 equals m, because 1 times m is m. So again, we even simplify at the end. 1m means 1 times m, and that gives you the m by itself. And that's how you know you're done. Once the variable mathematically gets by itself from a series of doing inverse operations and simplifying wherever you can, once that variable gets by itself, that's when you have solved the equation, because that's when you find out that the variable equals whatever number it equals to make the equation true. Okay, I've talked you through 2 fully typed up examples. It's time now to do a couple together. Problem number 3. It's on the first page, and I believe there's a little bit of room on the left for you to write out the thought process, which is going through what's happening to the variable, WHTTV if you want to abbreviate. So what's happening to the variable n? Well, it's being divided by -8, then added by 25. So let's write that out. First being divided by -8, then being added by 25. That's the order of PEMDAS. But inverse operations will be in the inverse order. And the inverse order of PEMDAS would be SADMAP, which means we're going to first inverse adding by 25, which would be subtracting by 25. Then we will later do the inverse of dividing by -8, which we all know the inverse of division is multiplication, so that would be multiplying by -8. All right, let's do the first inverse first, all right, because that makes sense. So the first inverse we said was to subtract by 25. Let's now do that on both sides. Now, before we work down, can you please check your alignment? The equal sign separates the left side from the right side, and so make sure you lined up one of those subtracting by 25s on the right underneath the -36, and then the other subtracting by 25 should be under the adding by 25 because that's the part you are inversing. Please do not put the -25 underneath the fraction because that's not the part you're inversing at that moment in time. All right, before we work down, find the subtraction pieces. Here we have one, subtracting by 25, make that adding the opposite. Here's the other one, make that adding the opposite. Now let's work down. -36 plus -25. When you have a negative plus a negative, you'll add in your head, and it will stay negative. Please do not think that two negatives become a positive when you add. Two negatives would become a positive when you multiply or when you divide, but here we're adding. So -36 plus -25 is -61. On the left-hand side, +25 plus -25 gives you 0. But the n over -8 is still there. Please do not make that -8 disappear. It does not disappear. Now, here's what could kind of disappear. When you add by 0, anything plus 0 is the thing itself. So the fraction plus 0 is just the fraction. So simplify that. So now we just have n over -8 equals 61. And now it is time for us to finally do the second inverse operation, which is to multiply by -8, because that's the inverse of dividing by -8. So let's now do that on both sides. Okay, let's work down. A negative times a negative is a positive. 61 times 8. 8 times 1 is 8. 8 times 6 is 48, so that would give me 488. And like I said, that's a positive. If you don't want to put the tiny little positive symbol, you don't have to. The left-hand side, the fraction times -8, will give you 1n. Now, if you're like, whoa, Mr. Underkoffler, why doesn't that give me a 64? I actually explained this to you guys on a previous lesson, but I'll explain it for you real quick. I'll do a little side work over here. If I had n over -8, and I multiply that by -8, that -8 that I'm multiplying by is the same as -8 over 1. And then if you multiply the numerator of n times the other numerator of -8, you would get -8n. And then the denominator, -8 times the denominator of 1, would give you -8. And then from here, you can reduce. The fraction bar technically means to divide. And -8 divided by -8 would make, that's right, would make 1. And you would get 1n. Now, do I need you to show this side work anymore? No. I taught you that a few days ago. You do not have to show that side work. I am not requiring it. But I wanted to show it to you here real quick on this video, just so that you can see that I'm not lying to you when I say that you're going to get a 1n on the left-hand side. You will. And then 1n means 1 times n. That can simplify to just n because 1 times anything is itself. So 1 times n gives you n. And that is how you solve this equation. We just found out n equals 488. All right, if you go to the second page, you'll see a bunch more problems. Let's do number 4 together. This will be the last one that I do with you. You will end up doing the rest on your own. Problem number 4. What's happening to the variable? Now, you'll have to write these questions off to the side. I did give you room. So write this off to the side. You can abbreviate. What's happening to the variable? Well, the variable is w, and we see this 11 right next to it. That means the variable is being multiplied by 11. But there's more. It's also being subtracted by negative 158. Now, those parentheses do not really matter. We talked about this before. Textbooks and worksheets across the world will put negative numbers in parentheses if they come to the right of addition, subtraction, multiplication, or division symbols. So that's why you see that negative 158 in parentheses. The parentheses do not really matter. So where was I? The second thing happening to the variable that I highlighted in green is that it's being subtracted by negative 158. So write that off to the side. Now, what's going to be the first inverse operation that we do? Will we do the inverse of multiplying by 11 first? Or will we do the inverse of subtracting by negative 158 first? Well, you remember the word inverse means to do the opposite. So we're going to go in the opposite order. The inverse of the second thing will be the first inverse we do. So the inverse of subtracting by negative 158 would be adding by negative 158. Please, 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 do not accidentally lose your negative sign. We are not inversing the number, we're inversing the operation. The inverse of subtraction is addition. And then, later in our work, we will eventually do the inverse of the first thing happening to the variable, which was multiplying by 11. And we will do the inverse of that later on, and that would be dividing by 11. Okay, let's start. All right, so let's start with the first inverse operation that we said we were going to do, which was to add by negative 158. So let's do that on both sides. I will get rid of all this highlighting I did up here on the original equation. So we'll add by negative 158 on both sides. Now, before we work down, check your alignment. Remember the equal sign separates the left side from the right side. So hopefully you are lining it up to the left and to the right. The adding by negative 158 on the left should be underneath the subtracting by negative 158 because that is the part that you are inversing at that moment in time. Before you work down, find the subtraction on the original problem and make it adding the opposite, which makes that adding a positive. Now when you work down, you will see that you'll get 0. Why? Because positive 158 plus negative 158 is 0. I guarantee you, if you would not have made the subtraction adding the opposite, then you would have accidentally thought that you were going to get like negative 306 or something, or 316 or something like that. And that would obviously have been wrong. You will get 0. This is why I keep teaching you guys to make subtraction become adding the opposite before you work down. Right hand side, when you have a negative plus a negative, you will add in your head. That's how I get negative 220. Now, before we do the second inverse operation, which is to divide by 11, simplify what you can simplify. When you have something plus 0, the additive identity property kicks in. 11w plus 0 gives you 11w. Anything plus 0 is itself. Now we will do the second inverse operation, which we had already said was to divide by 11. We will do that on both sides. Let's do this. 11 divided by 11 is 1. Negative 220 divided by 11 is negative 20. And then we can simplify this, because 1w mathematically means 1 times w, and anything times 1 is itself. So that will give you the w by itself. And that's when you're done. Once you find the variable by itself and what it equals, then you have solved the equation. That's what it means to solve an equation, to find the one and only number that the variable can equal that makes the original equation work. Okay, I have led you through a total of 4 problems. 2 of them were already done for you. The other 2 we just did together. It is time for you to hit pause on the video and do 5, 6, 7, and 8 on your own. So hit pause on the video, do those problems now, then hit play when you're ready to see how you did. Okay, let's see how you did. Problem number 5. I assume you already did 5, 6, 7, and 8 on your own. If not, you better hit pause now. Here we go. Number 5. What was happening to the variable? Well, this was a little tricky. The variable was over here. And right next to it was the 9. It is being multiplied by 9 first. Then, the second thing happening to the variable, if you continue to read to the left, and you're like, whoa, were you allowed to read right to left? Yes. The order of addition and multiplication does not matter. So you can read backwards. The second thing happening to the variable is being added by negative 61. Notice that is the order of PEMDAS, where you would multiply or divide before you would add or subtract. And that's the order you follow when you answer what's happening to the variable. From here, let's do inverse operations, or at least talk about inverse operations as you write these thoughts off to the side. The last thing happening to the variable will be the very first thing that we inverse. So the first inverse is to subtract by negative 61, because the inverse of addition is subtraction. The second inverse will be to divide by 9. Okay, let's do the first inverse first. We said we were going to subtract by 61. Or sorry, no we didn't. We said we were going to subtract by negative 61. Oh my goodness. Be very careful. Why am I saying be very careful? You need to have a slash for subtraction. And you also need to have a slash for the negative. You need them both. Because if not, then you are not doing what you are supposed to be doing. So please double check that you have subtracting by negative 61. And you need to line it up underneath the other negative 61, because that's the part you are inversing, and then you need to have the other one lined up on the right-hand side of the equal sign underneath the positive 128. Now, from here, before you work down, subtraction is the same as adding, the opposite. Same thing over here, add, the opposite. And guys, that makes this a lot easier to figure out, because subtracting a negative is complex sounding, isn't it? But adding a positive, that's easy. We can do that very easily. 128 plus 61 gives you 189. Negative 61 plus positive 61 gives you 0. 0 plus 9r is what you should get at this moment in time. That's right, the 9 does not magically disappear. And then 0 plus 9r can simplify to just 9r. That is the additive identity property. Anything plus 0 is itself. And now we will finally do the second inverse, which is to divide by 9. Let's do it. Divide by 9 on both sides. You will get 1r, because 9 divided by 9 is 1. 189 divided by 9 is 21. 1 times r is the same as r, and that's how you get the variable by itself. All right, moving on. Problem number 11. What's happening to the variable? Well, the L is the variable. It is over 15, so it's being divided by 15. Then it's being subtracted by 23. What's the first inverse? The first inverse is the inverse of the second thing happening to the variable, because you flip-flop the order, as I've been telling you guys over and over again. Because inverse means do the opposite. So that's why the order gets flip-flopped. And then the second inverse will be the inverse of dividing by 15, which is multiplying by 15. Okay, let's do the first inverse on both sides, and that is to add by 23. So here we go. Did you line it up properly? Did you put one of them underneath the left-hand side of the equation underneath the negative 29? Did you put the other one underneath the minus 23, because that's the part that you are inversing? Before you work down, make subtraction adding the opposite, so that way you can see how the math works. Because if you don't do that, then I highly doubt that you're going to realize why you would get a 0 here. Negative 23 plus 23 gives you 0. On the left, negative 23 plus 23 gives you negative 6. L over 15 plus 0 becomes L over 15. Anything plus 0 is itself. Always simplify before you do the next inverse. And the next inverse is the inverse of dividing by 15, which we already said was going to be multiplying by 15. So here we go. Do it on both sides. Negative 6 times 15 is negative 90. The right-hand side gives you 1 L. If you don't remember why, I did explain that over on number 3 when I talked about that earlier in the video. So you'll get 1L. 1L means 1 times L, which is the same as just L. So you get the final answer that negative 90 equals L. Problem number 7. What was happening to the variable? It was being multiplied by negative 25. Then it was being added by negative 56. The parentheses do not really matter. I talked about that earlier in this video. First inverse is to subtract by negative 56. Then later, the second inverse will be to divide by negative 25. So let's see. Did you do the first inverse first, which was to subtract by negative 56? And I talked about this before. Do you have a slash for subtracting? And then do you have the other slash to show the negative 56? Now, yours probably doesn't look like that anymore. You probably already made subtraction become adding the opposite. So that's going to become adding positive 56 and over here adding positive 56. Hopefully you have it lined up properly underneath and adding by negative 56 and adding or underneath the 119. You work down, you will get negative 25a is still there, plus 0. 119 plus 56 gives you 175. Then anything plus 0 is itself. So negative 25a plus 0 gives you negative 25a. Now we will do the second inverse operation, which was to divide by negative 25, because that's the inverse of multiplying by negative 25. So do it to both sides. Negative 25 divided by negative 25, forgive me guys, I'm struggling talking here, will give you 1a, and then the right-hand side, think of quarters. 7 quarters would make $1.75. So 175 divided by negative 25 gives you negative 7. 1a is the same as a, and there you go. Last problem, number 8. What's happening to the variable? Well, since the 1/2 was right next to the variable with nothing in between, that means the h was multiplied by 1/2. And then to the right of that, it was being subtracted by 8. First inverse, add by 8, then later divide by 1/2. Because again, what was second will be inversed first. What was first will be inversed last, as I've shown you guys before. Okay, add by 8 on both sides. That's what we said we were going to do first. Hopefully you have it lined up just like you see here on my screen, underneath the negative 34 and underneath the minus 8. Speaking of the minus 8, make that adding the opposite. Now let's work down. Negative 8 plus 8 is 0 on the right-hand side. Negative 34 plus 8 is negative 26. 1/2 h plus 0 can simplify to just the 1/2 h. Now we will do what we had said was going to be the second inverse operation, which was to divide by 1/2, because that's the inverse of multiplying by 1/2. So check to see, did you divide by 1/2 on both sides? 1/2 divided by 1/2, anything divided by itself is 1. Left-hand side, I hope you didn't accidentally get negative 13. Dividing by 1/2 is not the same as taking a half. Taking a half is actually the same as multiplying by a half. Now, if you're like, what are you talking about, Mr. Underkoffler? I will tell you exactly what I'm talking about. You might have learned before that division is the same as multiplying by the reciprocal. Therefore, negative 26 divided by 1/2 is the same as multiplying by the reciprocal of 1/2, which is 2 over 1, or just 2. And that is how you get negative 52. You don't believe me? You can punch that into a calculator. I'm talking about punching in negative 26 divided by 1/2. I guarantee you it will give you negative 52. And then 1 times h is the same as h. And that is how you get the final answer here of negative 52 equals h. And that is the last problem on these guided notes, which means we are at the end of the video. Thank you for watching. We'll see you next time.